Okay, let's continue on, and now we'll talk about repetition. So repetition occurs in two forms, iteration and recursion. Iteration is when one function performs an action over and over again, or calls another function over and over again. Recursion occurs when a function calls itself over and over again. We'll only talk about iteration right now. So repetition allows the software to execute sections of code repeatedly. And again, it's there to allow the program to change its behavior based on user input. Typically, this is responding to changes of the size of data sets. So if I have a data set that has 20 elements and I have a data set that has 2 million elements, but I want to do something to each element, I have to change the number of times that the program executes some sections of code, and this is the easy way to do it. Typically, we use for loops. For loops are used when you know the number of iterations ahead of time. That doesn't mean you know it when you're programming it, but when the program is executing, it knows. So it knows the size of how many data elements are in a list, say, for example. The next more popular form is a while loop, and a while loop is used when you're not sure how often the repetition has to occur. You're waiting for some condition to be met. You're going to do this while some condition is true. You know, basically the condition is you're waiting for the end. So you use a while loop when you're not sure how many times ahead of time you need to do the loop. The two are absolutely equivalent. You can transform every for loop into a while loop and every while loop into a for loop, but they're just more natural ways to express the problem. Occasionally you can achieve this using recursion. Most modern programming languages support recursion. Again, that's when a function calls itself over and over again. Java supports recursion. We will not discuss recursion in this lecture. Okay, just like there were three things needed for selection, there's three things needed for repetition. You need a way to start it, you need a way to stop it, and you need progress towards the start to the stop. So you need a starting condition, you need some kind of a stopping condition, and then you need progress. Now, these terms are a little bit loose. The stopping conditions in loops are actually expressed as continuations. As long as something is true, continue. And as soon as that thing turns false, then you stop. Well, that's still a stopping condition, but you're really expressing it as a continuation. And also progress, there has to be progress, but that progress can be really random, right? Sometimes you're not sure if you're making progress or not. In a for loop, the progress tends to be explicitly stated and very straightforward. Okay, once you know that you're looking for those three things when you're looking for a new programming language, then it's simple. Now you're just looking for, okay, how do they do that? How do they get those three things? What are the syntax that I need to pay attention to? And in Java, the for loops have the start condition, stop condition, and progress right in the conditions set up for the for loop. So the for loop starts with the keyword for, and then open parentheses, close parentheses. What's inside those parentheses? The start condition, the stop condition, and progress. And then the loop body is the section of code that gets repeated. For a while loop, you still have those three conditions, but they're a little bit different. For a while loop, the starting conditions are set before the loop. Then you use the keyword while, and then you have the stopping condition. Inside the loop body, you hope that you have progress. Now, the progress in a while loop tends not to be as uniform as the progress that's in a for loop. Okay, so for example, here's a for loop. Let's calculate the sum of the first n integers. Yes, this is legitimate Java programming. N equals next input, so next integer input, next int. That's using the scanner that we talked about in the previous set of lectures. And we start and initialize sum is equal to 0, and then we're just going to add up all the numbers. The typical format, I is equal to 1. I is less than n plus 1 is your stopping condition. Now again, technically that's telling you when to continue. As long as I is less than or equal to n plus 1, you're going to continue. As soon as that thing turns false, you're going to stop. And then you say I is equal to I plus 1. That tells you that each time you go through the loop, you increment I by 1. And then you do the action. In this case, the action is just adding to the sum. We traditionally use I, that's called, to count how many times we went through the loop. It's called the loop counter. We traditionally use I for that. Now, I've been talking and saying that you should use descriptive names for your attributes and variables, and in this case, that's an exception. It is normal and natural to use I. Why? Tradition. Back in the days of Fortran programming, your variables could only be one letter and one number. And it was assumed in Fortran that the variables that started with an I, J, K, L, M, N were integer values. So you didn't have to declare them as integers, they were automatically set as integers. And because of I being the first integer value, people started using I for the loops, and that's stuck. So this is, again, this is just a tradition. This is telling people you understand programming, you understand the computer science community. So by all means, use I for your loops. If you need to nest the loops, then you can use J. And if you need to nest them again, you use K. Okay? This is a statement. This first thing is a statement. You're actually setting the value of I equal to 1. And you know it's a statement that does the assignment of setting 1 equal to I equal to 1 because it's a single equal sign. The second part is a Boolean test. Do this as long as this Boolean test is true, keep doing the loop. And then the third is another statement, I equals I plus 1. Now, whenever you're doing loops, the place that you're going to find you have an error is at the first iteration and the last iteration. So always check to make sure that you're setting your loop boundaries correctly, that the lowest and highest values that your loop counter can take on are correct, and maybe run some tests with that. Make sure that this thing makes sense. The stopping condition, again, technically it's a continuing condition. I is less than n plus 1. We're going to change that in a little bit. Almost always loops are used with arrays, and Java gives you a really convenient way to express this with arrays, so we'll talk about that. You can actually ask for the size or the length of an array, and you put that in there. But for now, let's stick with this. Now, any Boolean test can go there. Doesn't have to be I is less than n plus 1. In this case, it makes perfect sense, but any Boolean test can go there. And so you can put in some unusual Boolean tests. In fact, you can effectively convert this to a while condition. The stopping condition that you used for the while condition would go here. And this thing will just keep repeating and repeating and repeating until that condition is met. And then the end condition, or the progress. In this case, progress is equal to I equal I plus 1. And that's normally how that will go. You normally increment. By the way, Java provides a shortcut. Everyone got tired of writing I equals I plus 1. So I plus plus is shorthand for that. And normally you're walking your way through an array, so you're going to the next element, the next element, the next element, so you increment by 1. I don't know, 95% of the time that's what you're going to do, but be aware you can put anything there. You can say I is equal to I plus 2, I is equal to I plus 5, I is equal to a random number. You can put anything in there that you want. You rarely need to. We can do the same thing with the while loop. So here's an example of what a while loop looks like in Java. And notice you're doing the exact same thing, you're just doing it in the while format. We start out the same, we ask the user to give us a value. We set the sum equal to 0. And now remember, the loops always need three things: a starting condition, a stopping condition, and progress. In the for loop, starting condition, stopping condition, and progress were here in between these parentheses. In the while loop, the starting condition occurs before the loop. The stopping condition occurs in between the parentheses. That's your Boolean test. And you have to build the progress inside the loop. Now, this progress is very straightforward. You would use a for loop for it. Usually your progress is not nearly so uniform, and you just keep continuing some action until the Boolean test for the stopping condition is met, or quite frankly turned false. All right, that's it for this module's lectures. And do the quiz, and I will see you during the live lectures.